Okay, this is a video for the project assembly and the drafting, and this is Shane. Alright, so this should be what you can get after this video, and let's start the assembly. Alright, so after you open the NX, and you should locate your files all in one folder. And as here, I create a new file, a new folder for the parts. So let's create a new assembly file. And the first thing is, of course, inches. And then you can see the file extension is exactly the same as modeling files. So that's why we need a file name that easier to distinguish this assembly file from the model file. So I would keep the assembly there. So locking a lock pliers, and of course you want to find your folder. Okay. All right. So since we don't have anything open, you cannot see any loaded parts. So we will use this open the file to find all the parts you want, and you can either import one part each time, or you can select them all. So I'm gonna insert this one first. Okay, and as for the bottom, you can just leave them as default. All right. As you can see, all the sheet body in the part will come along with the parts. So after you inserted the part, I would change the select filter to sheet body, and the box select everything. Then it's a little bit different from modeling. You don't have the hide option in the menu, so we'll go to the toolbar and hide. Okay, that's much clearer. Then I'll set the filter back to nothing. Okay, so if you remember the slides, the position of this handle is actually facing the right side. So I'm gonna first move this handle, or let's say move this component. So we have a assembly file with a lot of components inside. And how to move a component? We have this command on the toolbar. The other option is you can click on the part. You have this shortcut menu, and we have the move here. You can also put assembly constraint and hide. You can change its color. Okay, so I'm gonna move, and by default you will be using a dynamic, which is actually 6 degrees of freedom. You have the translations, which are arrows. Then you have 3 bars for the rotation. So I'm gonna drag this ball here to rotate the part along y-axis, and that will be 180 degrees. Okay, apply, and next I would like this part, the middle of this edge, to be on the absolute origin. So let's change a way to move the part point to point. And here I'm gonna pick the component first. Okay, so from this part, this point, as you can see, we have the snapping tool here. That's the midpoint. From this point to here, you cannot really pick anything. So I'm just gonna open the point dialog box. By default, it will be the absolute origin. I'll just click OK, and it just jumped to the origin. That's good. Alright, so this is the first part we inserted, and we placed it to the location we wanted to. And next, we can insert more components. But before that, I would like to constrain this part. you can imagine this working space as a universe, and all the components actually has nothing to anchor to. So it can free float in this working space. So I would like to fix at least one component, or usually you just want to fix one component. So that will give us an anchor point for the whole assembly. Okay, so this part will not move. And let's go ahead and add more components. That's this icon here. We can open the folder you want to locate to the folder that contains all your components, except I'm not gonna pick this one. Then I'll just insert them all. Okay, it's kind of messy. Again, first I'm gonna pick up the sheet body and hide them. If you like shortcuts, you can use Control B. Okay, then alright, so we have those things. So first I'm set this back. We are going to move the components around so they don't tangle together. Okay, apply, and I'm gonna pick up the jaw, specify the orientation, and move this. So move this. You can even pick and drag the center point. You might move on the Z direction also, so just beware of that. And last part. Okay, so as you can see, generally this is a symmetric pliers with respect to XY plane. So I would like to make sure all the components are centered with on XY plane. So what we can do is we will introduce assembly constraints. So we do have one center here, which is a little bit confusing on this 2 to 2 2 to 1. So we'll pick 2 to 2 to center the lower jaw. So the first two means you're gonna pick two faces or two objects. I'm gonna pick the top and the bottom face of the lower jaw. Then the second two will be another one. So I'm gonna pick this two face, the top and the bottom face of the metal handle on the jaw handle. Since this one is centered on the origin, so those two faces are centered to the two faces on the handle. Okay, and no matter how you move this component, okay, you can move X, Y, but you cannot move Z. Nothing will change. Okay, so that's the first, and I'm gonna continue adding the center constraint for pretty much all the parts. Okay, and here we can try another one like 2 to 1. So we can pick the top and the bottom face of the handle. Then the 1 we can pick the center point of this line, this edge, on this edge. Apparently it's not picking the point, so I'm gonna enable this snapping center point. Okay, so you have multiple choices. And as to this three piece, I'm not gonna center them just for now because it's actually not symmetric if you look at the small cylinders. Alright, so next the holes. Okay, we have two options to center the holes. Well, first is fit. Fit is for cylindrical surfaces with the same diameter. And the other one is concentric. Concentric, you can use this for circles with different diameters. Um, they will put the circles on the same center. So if you have those two holes, you know they are the same diameter, you can use fit or you can use concentric. That's fine. But you want to put the small hole inside of this hole, you have to use concentric. Okay. So now I'm going to use fit, and that will be for the faces instead of the edge. Okay, as you can see, it just jump over here. Alright, and I'm gonna move this a little bit this way. Okay, and here we can have a look at the center. Okay, I'm gonna hide the jaw handle. And the other thing is we can create a cross section for the working piece, so we can see clearly what's inside. Okay, so let's go to View, Sections, New Section. Okay, so by default, you can have 3 default views like X, Y, Z, not plane, X, Y, Z normal. So if you pick Z, that will be X, Y plane, because Z is a normal of X, Y plane. So we can just click OK, and you can see what's inside. So remember the lower jaw, we have a circle here, which is actually slides on the jaw handle on this surface. So what we do for this kind of mechanism, we can use touch align constraint. And you have options. So I'm gonna use preferred touch, or touch will be fine too. So preferred touch, I want this cylindrical face to touch on this edge, on this face. Alright, so what's next? The same for this stopping block. Okay, in the real thing, this face will be sliding on this face. So again, touch align, prefer touch, pick the two faces. Okay. All right. Now next for this 3 parts, and I'll need to move this away a little bit. And as you can see, the lower jaw stays on the surface here. Alright, so, and I don't need this cross section, we can just double click, it comes back. Okay, and the other thing is you can change the color of a component. If you click, we have the shortcut menu, and that's edit display. We can change the translucency, we can see what's inside. The other way is you can change this to wireframe. Okay, maybe wireframe. Alright, so let's put up the connection bars. So here I'm gonna use concentric to demonstrate this constraint. So I'm gonna pick, we know this edge goes into this hole, so I'm gonna pick the edge of this cylinder, then pick the top edge. Okay, so as you can see, first they will be concentric, second they're coplanar. Okay, and so since we have the center constraint for this handle, you don't need another center for this. And let's try to move this on the Z, nothing happens. Okay, Y, sure. And for this side, wireframe, and we're going to put another one. So there's really no constraint that you can you can constrain this cylinder with move inside this slot. So what I'm gonna do is compromise the way, just see. Let's move this up a little bit first. Rotate. You want to move to the general position you want to put this part, and put a constraint. We'll be using preferred touch. So I want this cylindrical face to touch the inside of this slot face. Okay, and it's not perfect, yes. And if we move this, okay, you can see it will go outside. Okay, but that's the best I can do. And let's go ahead for the next part, which is this one. This guy here goes inside the handle, but also you have a hole, assembly hole here. So we'll just put concentric, because remember, concentric will make the circles coplanar. If we use fit, okay, see what happens. Cylindrical face, cylindrical face. Okay, it's inside. And what happens if I move on the z direction? Yes, they are. The center line of the cylindrical face are aligned, but it's just you know, they can still move on the axial direction. So I'd rather just put a concentric, which also eliminates the axial movement, and we can deal with that later. And again, concentric for this part to the top edge. Okay, so almost there, and I'm gonna use this. Double click on the section. You can activate the cross-section view, and here when the pliers is not locked, it will stay around here. This block, this face will not touching this arc. If it's locked, this face will actually touch this. You can put this to a locking position, which is touch. So I'm going to pick this face, and you can pick this face. And as you can see, we do have multiple solutions for the touch. Okay. So that is not very good. I'm just going to leave this as is, or just manually rotate. And also you can see the interference from the section view. And as to this part, you really don't have much need to adjust the position. Alright, so of course the real thing, you might have the teeth engaged. Okay, and I'm gonna move this part to a better location, which is here. So the purpose of this assembly is not to make the pliers move like the real thing, but as close as you can, because sometimes, like for this part, let's just move this up a little bit and rotate. So in a real thing, there is a gap between the two gears before they lock, and this stopping block is actually acts like a wedge. If when the gear engaged, you'll be looking like this. It gets closer to this stopping block, and because of the slope on the gear, it will stop the moving of the jaw. So by nature there is a gap um, between this on the unlocked position, so we cannot really simulate that. Just to put a nice position for, you know, adjust this to a closer position. That'll be good enough. And also move this a little bit back. Apply, pick this up. Somewhere here. So that is good enough for me, and you don't need to show the movement of the moving mechanism of these pliers. In the report, you just show a reasonable position of your plier. Okay, and if you want to put your name on that, feel free to. You have the text tool, or you can extrude your text and unite the extrude to your swept. Alright, next is the drafting. So after we made the assembly, you want to create a drafting. In the report, we will ask you to create a drafting for a single part instead of the whole assembly. But here I'm just gonna use this assembly to demonstrate how to use the drafting. So to initiate the drafting application, okay, you go to start, then there's drafting. Since we are already in drafting application, so you can see modeling. We go back to modeling. This is where we were. Then we come here, drafting. Then it will ask you for the size of the sheet you want. You want to use a template with a huge Siemens logo on the bottom. Okay, I'm gonna use a standard size. Well, okay, template. Then we can put names on that. So which size you want, you have the option to use two methods to create your views. So the default is creation wizard. If I click yes, okay, so you can use you have this to put in, and you can say draw by whom, okay, and after this you can choose which part you want to create. Yeah, since we have the assembly open, so all the parts are loaded, you can pick either one of that. And next is the view. Okay, that's the line width, style. You want to see wireframe, or you want to see hidden wireframe without. And this is the preview style. It's not the it's not the what you will see last. So orientation, you can go for the top view, right view. Okay, let's just do top view. Next, you want how many views? Okay, so I don't need that. Probably this 2 is enough, and I can hit finish. So that's what you will see on the final view. Okay, and if you hide one thing, it will change as what you do here. It's the same in for the parts. If you go to the parts, if you have some like extrude here, you can hide the extrude, then the extrude will hide. Okay, all right. Now we have two views. Okay, and we can add dimensions. And the dimensions, we have decimal style or you have fractional style. Let's have a look if this thing is. Uh-oh, that's my game. Alright, it's still recording. Okay, you can change your annotation to decimal or default is decimal. You can change that to fractional. Come to the units tab, and the position is here in the dimension tab. So this is the overall setup. Okay, if you change this to fractional, and also the precision will be 1/16. Now whatever the dimension you add, you will add dimension from here for dimension. If you pick this, that'll be fractional. Of course, this is fractional. And sometimes you want one dimension to be different from the other. So let's say that's the total height of the pliers. I want this to be decimal. So we can click on the dimension itself, then we have the style button. And in here, you can go to units, change this to decimal again. And also you have the option to change position here. You can go to the fifths. That's the decimal dimension. Then you have the fractional dimension. Okay, so that's pretty easy. And sometimes you have a cylinder looking from the side. Okay, let's say this is a cylinder. If this line represents the top surface of a cylinder, you can't use this infer dimension to give you a diameter sign. So we can use this cylindrical dimension. If you pick one line, I guess 2 point, cylindrical dimension, you can pick 2 lines, and as you can see, we have the big diameter sign here, okay, which is not true because this is a line. So that's the way you can force the system to give you a diameter sign here, and diameter symbol, I'm sorry. Then you have some roughness, stuff like that, and you have some reference line like circular, center line. Okay, for this course you don't really need them, and maybe what you need is here, the section view. So what if I want to cut, let's say I want to cut this open. Okay, I want to make a cut on the symmetry plane. So we can activate the section view command, and remember we have two views here. So first you want to pick which view you want to cut. I'm going to pick this. Then you have the cutting plane, and I'm going to pick the middle point of some line here. Then you can change the angle of your cutting plane. So there we go, and that's not very good. Okay, cutting plane, click the point, and you can drag to the position you want. Okay, that's the cross section. And bear in mind that I have the boundary line here because I didn't unite those swept to the extrude. Okay, you might not have those boundary lines here. Okay, so we have the cross section, and the crosshatch means that's the intersection of your assembly to the cutting plane. And what's that? That's behind your cutting plane. Okay, we can see those things, they are not on the cutting plane. Sometimes we want a very clear cross section without anything behind this cutting plane. What we can do is we can click on the view. Again, we have the style button, and in the style we have a lot of options, and in this section tab we can uncheck the background and you click apply. As you can see, we don't see the lower jaw that's behind the cutting blade, and the same to the handle. Alright, and okay, I have two views from the wizard. What if I need another view, like a 3D isometric view? So come to here, we have the base view command. Okay, so base view, you can change, you can just insert any view you want. Let's say isometric, and you can change the ratio, the scale. Okay. Also, let's drop this first. Sometimes you can pull out, yes. Sometimes, like for this isometric view, I want a nice shaded with the colors. Okay, so we can change the view. Again, click on the view. You have the style button. Then a lot of options. We can go to shading. Here we can change the rendering style from wireframe to fully shaded. Click OK. We have the colorful view instead of the black and the white. Alright, so that's what you are going to do for a single part, and you will need to put a lot more dimensions than this. Okay, but we don't really ask for a fully constrained mechanical drafting, but you should make this look as pretty as a real drafting. Alright, so I think that's all for the assembly and the drafting. Thank you.